A galaxy is a condensate of gas and stars, which is kept together by gravity. We know that the gravity is due to a third ingredient on top of gas and stars, which is dark matter, some mysterious substance that keeps the galaxy together. We cannot create a galaxy in a lab. The reason is that galaxies involve timescales and densities and temperatures, which are well beyond the reach of current technology. That's why we have to do that in a virtual environment, which is indeed a computer. We decided, my research group and I, to try to understand galaxy formation across the whole galaxy spectrum, from tiny, tiny galaxies, the smallest objects we can see in the universe, up to galaxies as big as our own, the Milky Way. And that's NIHAO. NIHAO, it's an acronym, stands for Numerical Investigation of 100 Astrophysical Objects, but it's also the word hello in Chinese. So making a galaxy is not much different from baking a cake. For 100 grams of galaxies, 80 grams of dark matter, 20 grams of gas. So how do you bake your galaxy then is that you need an oven, a powerful one. And for us, the oven is a supercomputer. Then the next thing you need is some idea about the recipe. So in numerical simulation, what happens is the dark matter gets together first. Then the gas follows and concentrates at the center of this dark matter ball. The gas starts to transform itself into stars. Then when a star explodes, they put energy back into the system and the gas expands. So what you have is a continuous life cycle of the galaxy. The problem with the sky is that it's 2D, and that is a huge limitation to try to understand. The other problem in the sky is that you get overlapping objects. So practically you have objects behind objects, behind objects, behind objects. Keep going, right? That's also another big problem. The other problem that you have in the sky is that you're limited by the power of your telescope. In a simulation, practically we have infinite power. We see everything which is actually in the simulation. Another advantage is the same as time reversal. So we are not stuck one point in time, but actually we can just, in the movie, moving your mouse, you can keep going back and forward and trying to understand, for example, which part of the galaxy came from. So we have a full history. Now we're trying to move to phase 2. The idea is that we want to include more physics into our numerical simulation. Because the whole game of simulating is that you cannot simulate the whole set of physics parameters that actually enter in the galaxy. The reason is that would be overwhelming. For the computer, also as a time scale, it will take years or decades to get a result. So you have to make choices. Now what you can do step after step is to refine your recipe. So the next step we're trying to do now is to add the physics of black holes.